Recording again. It is visible, right?
Yes, sir.
Okay. So this is regarding what is data exploration. A preliminary exploration of the data to better understand its characteristics. So whenever data set is given, then first we should find out what is there in the data, what are the characteristics of the data. To know that process, it is called data exploration. So you are exploring the data to find out its characteristics and what is there in that data. So what is the motivation for this? Helping to select the right tool for pre-processing or analysis. So when you understand the data, you know that what data pre-processing should be done for that and what analysis tool you can use for that data. Making use of humans' abilities to recognize patterns. So it will also help you to recognize patterns. So you may find some patterns in the data. So that is another advantage. People can recognize patterns not captured by data analysis tools. So this is also called EDA, exploratory data analysis. In simple data analysis tools, may not be able to capture, but you should be able to capture through exploratory data analysis. Related to the area of exploratory data analysis, this is actually created by John Tukey. There is also a book, seminal book is Exploratory Data Analysis by Tukey. For a data scientist, the first step is the EDA. If we cannot perform EDA very well, then all the mistakes will happen for the future tasks, whatever we do. So as a data scientist, we should know the techniques of how to explore the data. So I hope that if you can get online copy or some PPTs about this book, this Tukey, then it may be a good idea for us. It is really mentioned here and whatever he has taken from that book. So you can also try, find out this. I'll share this PPT so that you'll get that name also. So what techniques we'll use in data exploration? In EDA as originally defined by Tukey, the focus was on visualization. So by looking at the data, it becomes easy for us to find out whether it is linear, whether it is a bell-shaped curve, all those things, or how the data is spread over. Instead of looking at the numbers, when you look at the plot, then it becomes easy for us to grasp the overall representation of the data. Clustering and anomaly detection were viewed as exploratory techniques. So we can also get it, say, instead of taking statistically, look at the data and see that what the points are deviating too much from the normal behavior of the data set. That is outlier. Even clusters also, you can see that are there normal, naturally formed clusters in the data or not. Getting clusters, you will get anyway clusters in k-means, but do they really make any meaning? For that, we may need to see that our data visually and see that are there any naturally formed clusters. In data mining, clustering and anomaly detection are major areas of interest and not thought of as just exploratory. This exploratory analysis is not enough to find out just clusters, find out full clusters and anomaly detection, but it will help for us initially to find out are there any naturally formed clusters, are there any outliers. But those itself are very important algorithms in data science. So what we study in this is summary statistics, visualization. Of course, we don't focus on this OLAP, but earlier days when people were calling data mining and data warehouse, in data warehouse, this OLAP was important, online analytical processing. So nowadays, this OLAP has not been that important, but still, there are people managing data warehousing at warehouses. Those people, it is important. We will just touch what is this online analytic processing at the end. Summary statistics, it's a, whenever data is given, the important things which will be interesting for us to see that, what is the statistical summary of the data? Summarized properties include frequency, which is the highly frequent number, location and spread, how the data is spread. All those things are called summary statistics. Example, location means mean. So it is around what number, below and above. Mean is middle, right? Not median, but mean means average value. Median is exactly dividing elements below 50 and above 50%. Then spread, standard deviation. How much of deviation is there between numbers? That is called standard deviation. So these are the things which we need to give immediately when the data comes to us in exploratory data analysis. Most summary statistics can be calculated in a single pass through the data. You know that there are many packages which will give you all these numbers whenever you give the data to the algorithm. The frequency of an attribute value is the percentage of time the value occurs in the data set. For example, given the attribute gender and a representative population of people, the gender female occurs about 50% of the time. So this is frequency of male is 50%. Frequency of female is 50% in any population, most of the times around. The mode of an attribute is the most frequent attribute value. So if you take our class and all the names, the name which will appear most of the times, then that is the mode, if you consider only names of people there. So which is the element or which value is appearing most number of times, that is called mode. The notions of frequency and mode are typically used with categorical data. So this frequency or mode mostly use it in categorical data. So because in missing values, yesterday also I discussed it, in categorical values, if there is missing value, with what you will substitute or impute, then one way is most frequent value in that means mode, fill by mode in that column, or highly frequent thing, it's a, if there are many modes. Then one more statistical summary is called percentiles. Percentiles has its own importance. You might have heard that it's when you write a GATE exam, then they'll give you percentile score. Percentage is different from percentile. So what is the meaning of percentile? For continuous data, the notion of a percentile is more useful. Given an ordinal or continuous attribute x and a number p between 0 and 100, the pth percentile is a value xp of x such that p% of the observed values of x are less than xp. So that's why you won't get in GATE score 100 percentile, because 100 percentile means below you 100% people are there. So it will tell you that it's how much percentage people are below you, because even if one is there, you yourself is one. So there will be only 99.999% only below you. So you cannot see that 100 percentile score, because the definition is how many values are below than that number. How much percentage of values are below than that number is called percentile. The important things are, let's say, the median, that is 50th percentile, means 50% of the values are below that number. Then that value is called 50th percentile value. Then 25 percentile, that is first quartile, 75 percentile, that is third quartile. So they are also important numbers. Then measures of spread, range and variance. So what is the minimum and max value? What is the difference between minimum and max? And what is the variance of the data? They are called spread. Range is the difference between the max and min. The variance or standard deviation, SX, is the most common measure of the spread of a set of points. Because of outliers, other measures are often used. Then variance definition is given here. Then another is called AADX. Then that is absolute average distance. This is AAD means 1 by m, I is equal to 1 to m, xi minus x bar. There is still, let's say, some debate. Variance doesn't represent actually, because you are making all squares. So when you make squares, then it amplifies the differences. That's why it may not exactly give you. So we should use AADX. So there is still some debate in data scientists whether to take variance as the spread or AAD as the spread. So nowadays, it's people are little bit moving to the AAD. But it has its own problems. Mathematically, this mod function is not differentiable. Those things will come, but coming to the representation, it will give you exactly the differences between values, right? Here you are amplifying them by taking squares in variance. So absolute average distance is also one of the important spread thing. Then median average distance, then instead of the median of means you are taking median of average distance. So x1 minus x bar, you are removing the average and you are taking the values, the differences, whatever comes the median in that you are computing as MADX. So interquartile range is nothing but 75 percentile value minus x25%, means 50% values are falling between these two values. X25 means 25 percentile value and 75 percentile value. What is the range between means what is the x20, what is the difference between x25 percentile or 25 percentile value and 75 percentile value? So that is regarding this summary statistics. The first step in EDA is provide the statistical summary of the data. Statistical summary is 3 parts. One is the frequency, location, and spread. So frequency will give you mode and frequency of values. Location means mean, spread means standard deviations. So in standard deviation variance, we have defined variations like AAD and MAD. So these are also people are using nowadays. So we may need to have idea about them. It's say if somebody is using AAD, we shouldn't say that it's I don't know what is AAD. So this is what we studied, and range and variance. Range is nothing but max, min. So that gives summary of the statistics which we need to provide immediately after the data set comes by using exploratory data analysis techniques. Then how to present the data. Visualization is the conversion of data into a visual or tabular format so that the characteristics of the data and the relationships among data items or attributes can be analyzed or reported. You may see that max, min, but if you see on a plot, then you will actually get some idea visually, it's how far they are. Visualization of a data is one of the most powerful and appealing techniques for data exploration. Humans have a well-developed ability to analyze large amounts of information that is presented visually. So that's why visual presentation is important. Can detect general patterns and trends, can detect outliers and unusual patterns. So that's why I asked it first, you need to add for your toolbox now, EDA tools. Then EDA presentation means visual summary statistics and visualization should be given at first, it's in your toolbox whenever the data set is given. That will give you overall picture for the, for the novice, I don't know, but at least for data scientists, what techniques we are using, how much they are helping us to build a good model. That will give some idea. Then sea surface temperatures. Thousands of data points are summarized in a single figure. Okay, now what will you identify from this visualization? As you are close to Mediterranean line, what do you call Mediterranean line, right?
Yes, sir. Yes,
sir. So what is happening in this temperatures? More red means more high temperatures. Yeah. So this is giving a summary. What type of summary we are finding from this visualization? Around Mediterranean line. How are the temperatures?
If you go far from Mediterranean line, then temperatures are low.
Right, almost zeros.
Yes, sir.
Okay, yeah. So giving numbers for each country, will it be useful, or this is useful more for the people to perceive these temperatures?
This is easier to get a summary of whole data.
Yeah, this gives easy way to understand, right? These sea surface areas, that's why it's you can see Africa, South America, North America, all these things in India here, right? Is the mapping of information to a visual format, representation of the data to visual format. So we are mapping the data to visual format in visualization. Data objects, their attributes and their relationships among data objects are translated into graphical elements such as points, lines, shapes, and colors. Now their C's has become our points in the, right, that whole thing, that area. Then temperature they represented. So once we want to visualize, then we should convert our data into points, some graphical elements like shapes, colors. Examples, objects are often represented as points. Their attribute values can be represented as the position of the points or the characteristics of the points. Example, color, size, and shape. So here temperature we are showing with a color, right, instead of the numbers there. So high red, then high temperature, blue, low temperatures, zero temperature. It is close to red, then high temperatures, close to blue, zero temperatures. Something like that. So we converted those temperatures into color there. Then let's say sometimes if they want to show countries with population, high population with a high figure means big size figure, low population with low size figure. So size of the point or size of the shape will represent the population. Like that also people will use their size matter. Then shape. So if you want to represent with the different classes, then different shapes they put it. So visually they want to identify or map the original data to graphically identifiable objects. If position is used, then the relationships of points, that is whether they form groups or a point is an outlier, is easily perceived. So if you take the position, means exactly the mapping is equal to the where they are located position, then finding outliers becomes easy. Then how do we arrange is the placement of visual elements within a display. So whatever you are presenting, that should be able to visually see them in a display. In such a way you need to arrange. Can make a large difference in how easy it is to understand the data. So if you see an example, what is difference between first one and second one? If you arrange like second one here, what advantage you are getting? So if you want to find out where are the ones in the first figure and where are the ones in second figure, is it easy by looking at the second figure?
Yes, sir.
Yes, sir. Yes, sir.
So you are getting nice, if it is a geographical locations, then you are getting a nice squares, right? This ones in the first left upper square and right lower square. Remaining things are zeros. So only thing is you are rearranging your features 6, 1, 3, 2, 4, 4, 2, 5, 4, right? Then it looks like it is easy even to count how many ones are there, how many zeros are there instead of this. So can make a large difference in how easy it is to understand the data. It's simple thing. It's a only table. The table itself, how you present, that makes lots of difference to understand what is there in the data. Then how do we select? Is the elimination or the de-emphasis of certain objects and attributes. Selection may involve the choosing a subset of attributes. Dimensionality reduction is often used to reduce the number of dimensions to 2 or 3. Alternatively, pairs of attributes can be considered. Selection may also involve choosing a subset of objects. A region of the screen can only show so many points. So can sample but want to preserve points in sparse areas. So when you take the sample, you should also take care that sparse areas also should be represented. Then histograms, one way of visualization is histograms. Why do we use histograms? Usually shows the distribution of values of a single variable, which value is, it is nothing but frequency. What is the frequency of each value for that variable? Divide the values into bins and show a bar plot of the number of objects in each bin. If it is a continuous, then make it discrete. Then get in each discrete group how many values are there. That is nothing but frequency of each discrete group. The height of each bar indicates the number of objects. Shape of histogram depends on the number of bins. Then if you take only in the first, how many bins are there here? 10 bins. In the second one, you have 20 bins. If you get less bins, then it looks like more uniform. If you get more bins, it looks like less uniform. It is same thing like your aggregating. So if you have less bins, means you are aggregating 2 bins together, right? In the right side has 20 bins, left side has 10 bins. Then 20 bins aggregated into 10 bins. That's why you see more variation in more bins, less variation in less bins. Is it clear what I'm saying?
Yes.
Yes, sir. Yes, sir.
Yeah. Then 2-dimensional histograms also can be done. All these packages are there. You need to understand right package and how to use. But first you should get idea that we can also visually show 2-dimensional histograms. Show the joint distribution of the values of 2 attributes. Example, petal width and petal length. So both together means there are almost here same, like between petal length width 1 and petal length below 3 is this much, then 3 to 5, then 1 to 1.5. These are exactly the classes also which we have seen at the time. This is the histogram of that 2-dimensional. Then this is again statistical approach to represent the data. Statistical summary it will give. Examples of box plot it is. Then box plot, the middle number is called median. Means before that half of the values, above that half of the values. Then the square lower is called 25 percentile value. Square upper thing is the 75 percentile value. Then this whatever you have, the top line, horizontal line, x horizontal line to x, that is the almost close to 100 percentile, means that is the maximum value, and the lowest is the minimum value. So minimum, then first quartile, that is nothing but 25 percentile, median 50 percentile, the next line is the 75 percentile. The box contains 50% values, box plot it is. Below box and above box together contain 50% values. So statistical summary can also be presented like this. Then whatever values you get, see above the low and minimum, they are outliers. Then you may ask that, see if outlier is there. So after removing the outliers, you find the min and max. Then whatever you remove them, they will look like outliers. If you see the second one, you can find the outliers. Then this will also tell you that some statistical spread. There is more density between 50 percentile and 75 percentile. You see the third one. And less density means the spread is more between 25 percentile and 50 percentile. What does it say? Why it is important for us? So if I want to get the class summary, say how students are doing good, I may be interested to see that how 50% below people are doing. Let's say below, it's bottom 50%. Then bottom 50% has more variance. Then top 50% has less variance. I can see it. So if I remove that, it's 75 percentile, above 75 percentile, they are anyway good students. They don't need any classes. They don't need anybody to them discipline. Then if I put them together, it's not worried. Then I may be worried below 75%. Then below 75 also, the 75 to 50, whatever is there, the small area, there are many people. They're almost, let's say, competing one another, those things. But to handle below 50 percentile, the variance is very high. Their capabilities, their discipline, their hardworking, all those things are very high. So one person may not be able to handle because their properties are different. But whereas 25 percentile and 50 percentile is very high, but 58 to 75 is very narrow, means they're almost the same. That's why even one person may help them, let's say, to improve their grades. So by looking at the box plot, statistically, we can find such things. So where is the more variance, how they are differing with one another. So in which part of the box plot they are dense, they are not dense. Dense means they are not much variance. Not dense means much variance is there between among them. This is the box plot thing. Is it clear? What about why we use the box plot?
Yes, sir.
This is particularly spread, how the data is spread. Okay. So visualization technique, scatter plots, then attribute values determine the position. Two-dimensional scatter plots most common, but can have three-dimensional scatter plots. Often additional attributes can be displayed by using the size, shape, and color of the markers that represent the objects. It is useful to have arrays of scatter plots, can compactly summarize the relationships of several pairs of attributes. So as I told you, it's here classes are represented with colors here, or shapes also. Plus is one class, then shapes, round is another class. So different things, it says scatter plots is basically position-wise plots. And you cannot visualize more than 2 to 3 dimensions. Anything more than that, people try to bring other dimensions like making shape different, making color different, making size different. So those will be addition for scatter plots. Then contour plots are useful when a continuous attribute is measured on a spatial grid. They partition the plane into regions of similar values. The contour lines that form the boundaries of these regions connect points with equal values. The most common example is contour maps of elevation. Can also display temperature, rainfall, air pressure, etc. An example for sea surface temperature is provided on the next slide. This is contour plot, means let's say between those that contour, it is one continent here, and the temperature same color here. The sea, if you remove the land areas, then you go only with the surface areas, sea surface areas. Then different colors are representing areas where they have same temperature. So contour means boundaries of those temperature sea surfaces with those temperatures. Then matrix plots can plot the data matrix. This can be useful when objects are sorted according to class. Typically, the attributes are normalized to prevent one attribute from dominating the plot. Plots of similarity or distance matrices can also be useful for visualizing the relationships between objects. Examples of matrix plots are presented on the next 2 slides. So how many such things are there? In sepal length, then how many virginica, how many versicolor, how many setosa. The colors are different for each one, right? Just now we have seen with ones and zeros. You are able to identify clearly where you find more ones, more zeros, like that here in this. More setosa, more versicolor, more virginica. Another technique is parallel coordinates used to plot the attribute values of high-dimensional data. Instead of using perpendicular axis, use a set of parallel axes. The attribute values of each object are plotted as a point on each corresponding coordinate axis, and the points are connected by a line. Thus, each object is represented as a line. Often, the lines representing a distinct class of objects groups together at least for some attributes. Ordering of attributes is important in seeing such groupings. So if you see example here, then parallel coordinate plots for iris data. Then you have 4 parallel things. Sepal length is the first division, then sepal width is second division, petal length, petal width. So as petal width, you see that it's again 3 colors. Setosa are having very small petal width, then versicolor has a medium petal width, then virginica has a high petal width. But that highness is not like high of the sepal length. You can also compare with it. Say, okay, petal width is high, but is that high as similar as to sepal length? No. Sepal length variation is more than the petal width variation. Not variation, but their values are starting from 4 to 8, but whereas petal width values are started with 0 to 4. Maybe variation same, but at least the start value and end value, the values what it is taking, you can see completely understand by looking at this. You don't need the data. So this is parallel coordinate maps. Then there are star plots, similar approach to parallel coordinates, but axes radiate from a central point. The line connecting the values and object is a polygon. So if you see, these are the star plots. Then how they spread again, whether x-axis or y-axis are more spread or equally spread. Those things you can find out here. So sepal width is very compact and sepal length may be very high. Those things you are able to get from the star plots. Chernoff basis approach created by Hermann Chernoff. This approach associates each attribute with a characteristic of a face. So the values of each attribute determine the appearance of the corresponding facial characteristic. Each object becomes a separate face, relies on humans' ability to distinguish faces. Okay. Then they are using, instead of these stars, they are using human faces to represent their spread, whatever that is. Like Setosa, we have seen small length, small widths, small faces. Virginica, again in that length is more varied than the width. So he has used these things. Then I'll stop it here. You can go through this OLAP. As I told you, we are not going to cover much about the OLAP. A very small introduction is there based on this OLAP. Please complete remaining 3-4 slides. But that is optional again. So I'll stop it here. If any questions are there, then I can take now.